Hi everyone. In our last session, we looked at the why we use a DBMS instead of a old dusty file system. So today we are looking at the how. So before a single row of data is ever entered, a database designer has to make a choice. How should this data look? This is where data models comes in. Think of a data model as the language of the structure. It defines the organization, the relationships between entities, and the constraints that keep everything from falling apart. Let's look at how these models have evolved over time. We started simple. The first major model was the hierarchical data model. Picture a tree turned upside down. You have a parent at the top and children branching at below. So the pros of this data model is it is incredibly fast because the path is direct. And the cons of this data model is that it only supports one to many relationships. A child can only have one parent. If a student belongs to two departments, this model breaks. It's too rigid for the complex world we live in today. So to fix that, we moved to the network data model. Imagine that tree, but now the branches can cross connect. It is a graph structure. So the pros of this data model is that now we have many to many relationships like this. You can go from here to there and there. So a student can have multiple teachers and a teacher has multiple students. But the cons of this data model that it is a mess to manage. The design becomes so complex that if you change one part, the whole thing might collapse. Then in 1970, a man named Edgar F. Codd changed everything with the relational data model. This is the model you will spend 90% of your career using. So instead of trees or messy graphs, we use tables. We call them relations. Everything is stored in rows like tuples and columns like attributes. It's very simple and it is mathematical and it is incredibly flexible. If you want to connect two tables, you don't need a complex map. You just use a common field, like the foreign key we discussed last time. This is the foundation of SQL databases, like MySQL, Oracle, and PostgreSQL. But wait, the world changed. We started writing code in languages like Java and Python, which use objects. So we created a object-oriented data model. It stores data exactly like your code with inheritance and encapsulation. And for the giants like Google and Facebook, they use NoSQL data models. Because when you have billions of posts and photos, a rigid table is not fast enough. So we use NoSQL. NoSQL gives us variety like key value database, document databases, column family databases, and graph databases. So key value databases is like a giant dictionary and document databases like storing data in JSON like files. As an example, you can say MongoDB. And in column family, it is optimized for massive scale like Cassandra. And then graph database, it is perfect for social network where the connection between people is the most important data point. So the examples are MongoDB and Cassandra or many more. Now let's talk about how we actually communicate with these models. We use SQL, but SQL is not just one big block of commands. It is divided into 5 specific dialects based on what you are trying to do. So the first is the DDL or data definition language. This is for the architects. You use DDL to define the structure. Commands like create to build a table, alter to change it, and drop to delete it. You can prefer this example. Create a table, student. It's mean create a table which name is student, and in that table we are storing ID which would be integer, and then we will be storing name, and we have a constraint for this name like varchar 20. So it is like a character limitation. So the name should be under 20 characters. That's why we are using varchar 20 here. And the second is DML. It is data manipulation language, and we use it to manipulate the data. And this is the most famous one. We have commands like insert, update, delete. We use insert command for inserting new data. Look here at the example. Insert into student values 101 Amit. So by this command, we are inserting data in this student table. So we are inserting 101 as the ID and Amit as the student name. Then we have DQL, data query language. We use this to retrieve data. And we have commands like select. Look at this example. Select asterisk from student. So here this asterisk means all. So it is basically saying show me everything from the student table. Then we have DCL, data control language. So we use this for permissions and security. So we have commands like grant and revoke. So grant gives a user permissions to see the table and revoke takes it away. Then we have TCL, transaction control language. This is for the what if scenarios. If you are at an ATM and the power goes out in a mid transaction, then TCL or transaction control language will save you. So we have commands like commit, rollback, and save point. So commit saves the work permanently, while rollback undoes everything back to the last save point. So we use data models to design the logic and data languages to execute that design. Now I have a question for you. I want you to think about a platform like Netflix. Now tell me, which data model would they use for their user list? And which language category would be triggered the moment you click add to my list? Tell me in the comment section.